Okay, we'll get started. The so we'll get started. I think the number of students is around 25 or 30. Am I audible, by the way? Okay, I'll try to. I know it's the room has somewhere. Okay, this is the system which is making a lot of noise in front of me, but um, so this is IDS 594. Actually, the course number is going to change hopefully for the next generation, but um, it has already been assigned. It's in the paperwork, but this is basically a course on MLOps. So I'll just start with the absolute basics. So I hope everybody has access to this Blackboard uh, um, site. So there's actually not much to do in the Blackboard side for much of the course, but I just wanted to walk you through the few tabs on the left side. So syllabus and materials is pretty much going to be our starting point every lecture, as well as for your own learnings. So you're going to start with that. Announcements and discussion board are straightforward. There is going to be a submission. There's one project component to this course. I'm going to discuss that when I talk about the course. And there is group information tab. I'm going to talk about that as well. So those two, uploading and group information, I'm going to discuss that because they're related to what you need to do at the minimum for this course. Okay, beyond that, there's a lot of things that you can do and learn, but there are a couple of things that you need to submit at least in this course. Okay, and finally, I do want to disclose that we tried to change the room to a room which had power plug points, but I could not. So I do have a Zoom link which you should be able to access. So it is, it's live. I think you can join live. There is no waiting room or anything like that. And there'll also be a recording. So I'll temporarily make being in person optional. Okay, that's only because we don't have plug points. I will try to get a different room, like some of the other rooms that you have seen other classes in. If we can, then in person is the default. Okay, but for now, even for today, if you wanna go somewhere else with a plug point and participate in the classroom, you can. Okay, so with that, that's just a Blackboard info. So let's actually try to zoom in, but didn't work. So with that, let me get actually started with the course. So I see some people who have taken some course of mine before. I think deep learning. I see a couple of people there. So this course is all about practice of machine learning. So really, we're going to not talk about any model building, evaluation, visualization, any diagnosis of the model building process, or even the models themselves. If you're building a model, let's say, if you're in the supervised learning paradigm. So nothing related to the ML expertise itself, but everything related to which is adjacent to the ML expertise. So if you are a data scientist today versus a data scientist 10 years ago, there's a new set of skills, adjacent skills that you need to learn. Okay, the computing platforms have evolved. I mean, today everybody has access to a really good MacBook or a Windows machine or whatnot, and also has access to GPUs, right? So things have changed, obviously, and also practices in companies where you would have the business analysts, you would have data scientists 10 years ago, and their day-to-day activity has been, is very different from what it is today. Okay, so most of the time is actually not spent on coming up with new models and experimenting on your laptop or something like that. So much of the time is spent on actually exposing that to users, consumers. It could be other departments, other colleagues of yours, or it could be actually end users of your company, your clients, or customers, right? So much of the time is trying to ensure that that pipeline is as robust and actually works most of the time, all the time as possible. Okay, so that's where and so that's where it gets a bit closer to some of the software disciplines we have in the university, but at the same time, we are not trying to be software engineers here. We just want to know what tools are available and what sorts of problems you have once you have already experienced building models on your laptop or somewhere else. Okay, once you already know how to build models, whether it's simple regression models or it could be deep learning models or somewhere in between. But after that, like, how do you ensure that things are consumed? It's deployed and so on. Okay? So that's what MLOps is. And it's really a course. It started as an experimental course 3-4 years ago. And so, software in general is always evolving. So every time you have a version update, Windows update, Mac update, but also all other apps also update, like even Zoom app updates, right? So the tooling also evolves. And so this course has some notes, which are actually in these folders here. So I'll talk about the site also in a second for those of you who are not familiar, but some of you might have already seen this website. It's called GitHub. It's just a place where, people, it's a social coding, I guess, platform. It's a social network. So in any case, there is material on this site, and this is the link that you would hit when you click on syllabus and materials on Blackboard. Okay. This area is a starting point. It tells you everything about the course, that you will be involved with. But also gives you starting points where you can branch off and investigate a lot of different cool technologies that are coming up in the MLOps space. Okay, so we know what the meeting time is and location. Office hours are 1:30 to 2:30, just before the class, basically, with a half-an-hour window in between. Or you can also email me, and we can have an appointment whenever, depending on our calendar compatibility. We can just set up a meeting. Okay. It's only an 8-week course, so it's really short. And the nature of the course is really hands-on, and that's why I initially mentioned that you need plug points. You need to have your laptops on. Unlike many other courses where you kind of shut down all the devices, here you need the devices because you will be trying things for more than 50% of the lecture time also. Okay, beyond after lecture time, when you should try things. So it's a hands-on course. It's really a lab course, but it's really helping you get started with trying out these tools. Okay, so that's the nature of the course. So that's why it's an elective. It chose to be in this course, and it's not a part of a core program or anything. So just to set context for MSPA folks, is this bright enough or it's not? It's not, right? But then I have to dim the lighting in the room. You can try that. Is this fine? Okay. The problem is looking at a screen with white background is kind of very tiring. But let's see how we get, how we move. So in terms of MSPA folks, 575, 572, 576, and some of the maybe even 561, they are relevant to this course if you've already done it. If not, if you've just started the semester, welcome to UIC, and hopefully you have some background in machine learning. I mean, it's not that we need anything sophisticated. You will learn that during your program, but you need to know at least what is simple regression. Okay, in just one-dimensional regression. As long as you know that, that's fine, because we'll do everything else around that. Okay, so we don't need to specifically talk about any specific model, statistical model or machine learning model. Okay. So there's a tentative list of topics here. Actually, this list, and I'm actually going to go through my, there's a slide deck in this, which I'm going to switch to. The slide deck link is also on this page, but let me not get into the topic list for now. There are a lot of names which some of you might not have heard of. If some of you are like already know this, then this is just going to be a little bit boring. But if you know some of these topics, then you should try to maximize your experience in this course by actually delving deep and becoming an expert in that topic or whatever. Okay. But for those who are starting from ground zero, that's where I'm gonna kind of spend majority of the time in the lecture. Okay. So let's actually okay. As I said, there are tentatively 6 lectures planned. There could be more. We can see what the last 2 lectures currently are for show and tell, essentially. So the project component, and that's why I'm going to talk about the project component in a second, but it's basically at least those two lecture slots have been reserved tentatively for you to show what tool you've investigated or tried out as a part of this course. And the tool can be anything out there. I mean, obviously, we're going to agree on some guidelines, and in previous semesters, I've even given links to a collection of tools from which students can pick. But it's mostly a show and tell component. So that's the last couple of weeks. Before that, it's a lecture session. But the lecture session, as I said, for now, it's optional for you to be in the class because you don't have power supply. But you need to be on Zoom for that. Each lecture, actually, a little bit less than 50% of the time is actually me talking, and that's where, I hope the boringness ends. And greater than 50% of the time is where you should try things which are being discussed. Okay. Because if you let it out, because I've seen that if you have to try something by yourself, you might hit software hiccups, and that might derail your sessions. So that's the I guess date structure. Topics, I'll not get into these. This is the same topics list that I'll also show in the slide. This has some lecture goals also mentioned, but I'll talk about the slide. I mean, I'll get into the details of the topics in a second. Let me actually just open the deck. Should not have clicked it. Okay, so course materials, there are two components. So this is the starting page. This has the course structure. There's a slide deck, and there's also another GitHub Git repository or a repository on GitHub. So this, by the way, this is called a repository, and the second link here is also called a repository. So those two, the slide deck and the second link, which is just a link, it's just a folder of codes, scripts, Python scripts. Okay. So it's just a folder of Python scripts, and we'll see how to download it and get set up on our own machine in a second. Those two are basically your starting points in this course. I always say starting points because there's a lot of details in each of these tools which you will not get into. And so I want to set the expectation that we are actually doing something basic in the class. And so if you're already an advanced student or you've already know some of these topics, you can go several levels higher, and you can discuss with me separately. Yeah. Okay. It's an 8-week course. There's only one deliverable, or basically a commitment on your end, which is you need to work on a project. Okay, a project in this class is not going to be similar to projects in the other class, at least project in other machine learning classes. So here, and there's actually a separate page here that you can explore in your free time. By the way, some of these links are just some other pages in this folder, okay, a repository. But the project is just as I said, it culminates in a show and tell. So what do you do for the 5 weeks or 6 weeks before that is pick up a tool of your choice. If you like images, you can look at image-based tools. If you like, some of the topics that you don't know, but I'll go through them today so that you can start thinking about what types of tools you want to try out. When I say tools, and I keep saying software tools, think of Tableau or Tableau is an example of a tool that you've already probably used before, or maybe are using currently as a visualization tool. So that's the type of tool I'm talking about. Okay, but there are also more software tools, as in like somewhere where you can do a little bit more configuration and so on. So that's the project component. That's what you're committing. So in the sense, at the 7th week and the 8th week, you're going to show and tell your friends here what tool you investigated, what did you learn from it, what's this, where is it used, why, what, all the basic aspects of it. Okay. And strictly 2 students to just manage complexity is just, helps you also simulate work environments. Okay. At work, you don't get to choose who you work with. Same here, probably, unless you have friends already in the class, then you can also, figure out your team, and then you can use that other link, this group information link. It's editable. So you just add your names here. Okay. So we'll come back to this because this is where I think there's some candidate projects already in the 3rd tab over there at the bottom. But we'll decide many things, some logistics about presentations, so on, using this sheet. And also grading. I mean, you and your teammate are in this together for the next 8 weeks. Okay. And so you get to decide a team. Obviously, because the project submission itself, I mean, you're going to submit a small document about your tool right before your presentation. Till then, obviously you can be flexible with your teammate, but it's good to kind of nail down who's going to be a partner and write it down here, and then work with them for what needs to be done for this course. Okay. Yeah, grading. It's I guess self-explanatory, since there is only one key thing that you are committing to. So that's what will be evaluated. The show and tell component itself will not be evaluated, as in your presentation skills are not being evaluated. You're just your familiarity, or your what did you do with the tool that you chose to investigate and play around with is what's going to be evaluated. And there is a component for course participation. So it says at the minimum, you need to attend, interact. There's no TA for this course this time, although the number of students is 30 or something. But you just need to kind of be active in this course. Okay. Any questions? These are just logistics. I skipped over the content because that can also give you a sense of whether this course is the right course for you or not. Because I don't know, how many of you are starting your semester this semester? Nobody? Okay. So that's good. So at least you have spent a semester here. So you have seen some courses. So I'll go through the topics. And so you can evaluate whether this course is not for you. If this course is not for you, you can drop it before whatever is the deadline to drop. Okay. Any questions about just the logistics? The 8 weeks of contact lecture session. As I said, each session is mostly little less of me talking. Hopefully today is a little bit of laying out, telling you the lay of the land, but less of me talking and a little bit more hands-on stuff. And because of the classroom, you could be optionally, take it from your home, wherever you have power supply, so that you have your laptop, you can try things. Yeah. So any questions? Yeah.
The project endings you mentioned the Excel sheet.
Yeah.
So do you need to pick up one of those project things, or you are free to pick up anything out of that list as well?
So the question for others is, I said, you're gonna try out a tool and talk about it even at the end of the course. There's a list of there's a list of tools there. Most of them are open source tools, at least source available or open source at the minimum. So that list is actually evolving. And if you have something else that you want to try out, you can just talk to me and we can include it as well. Okay. But that list is just, I started to see something. So I started with that list. Yeah. I don't want to click on the tab because there's a bunch of links and, you don't want to get defocused. Yeah. But you can just check with me if you have something else in mind. Yeah. But this project is not going to be like, it's not going to be like train a model, get insights from the model, show performance numbers. That's not at all interesting. And for the course or for the audience, it's more about if you pick a tool, like even Tableau, right? I keep telling, how many of you have heard of Tableau, by the way? Okay, somebody, yeah, okay. So even if let's say pick Tableau as an example, so we don't want to use Tableau to show some nice visualization of a specific, let's say you're analyzing geospatial, spread of, population density, some population density statistics or census statistics. Okay, we don't want to get into the details of census or population statistics or anything like that. It's just what does the tool enable? Okay, that tool enables slicing and dicing. It connects with multiple data sources. It does, it could do many things, right? So I don't know all the lists, but that's what we want to know, and that's what you should spend time on. Okay, not the details of some insight from the data or from the model. Okay, so that's the last time I'm going to talk about the projects, whatever the course structure. Then I'll get into the topics now. The mode of engagement, please ask questions. If you have a question, even in your mind, that means probably many of people have similar question. I'm not, asking for, I'm not checking your background right now, but, hopefully we'll calibrate so that if it's too slow, we can, speed up a little bit, or if it's, if things are complicated, some terms that you definitely don't know about, we can pause, okay? And what's the value of taking an MLOps course here versus on Coursera or YouTube or anywhere else is just the interactivity. There's a live person, who can guide you a little bit more if needed. Okay, so obviously today you have LLMs, right, which can also help you. Take advantage of them because this is a area that was not there 10 years ago or even 5 years ago. So it's or at least it was there, but very niche, restricted to some companies, but it's still evolving. Okay, so just I guess there are big companies that today are basically MLOps companies. So one of the examples is something called Databricks. So how many of you have done 561 big data course? Okay, at least 3, 4, 5. 5 people have done big data course, right? It's a requirement for one of your program, right? So one of the company which is built on Spark, provides Spark as a managed service on top of infrastructure provider like Amazon or Microsoft or one of these cloud providers. That company is worth tens of billions of dollars, right? So just one software which lets you do distributed training or data processing or whatnot is worth tens of billions of dollars, right? So just one company. I mean, there are actually thousands of companies in this space now, and a lot of funding and tools being developed for different segments, different users. Sometimes the users are data scientists. Sometimes the users are the infrastructure people in the companies. Sometimes the tools are actually for like even like a startup founder to kind of go from their small idea to actually get to a phase where they can actually talk to customers and get actually make the customers use your product. Okay, so a lot of tools in this space. Okay, so today's lecture is going to be a little bit different from subsequent lectures, because subsequent lectures I'll directly get into what's the objective and get into some code demos, and then you guys will try it out. But today I wanted to go through the topic names and at least some brief introduction to each of at least there are 5 or 6 buckets here, so that you can decide whether this is a course for you. Is it too advanced? Is it too simple? I mean, even if this course is for you, if it's too advanced, then you need to plan your expectation accordingly, right? How much effort you want to put in so that you can actually get something out of this course. So, let me get a slideshow. Yeah. So, what is MLOps? I mean, we've been using the word MLOps, and it's actually, there are multiple sources now of which define what MLOps is, including there are professional communities which have adopted it, and there are communities built around it who have now defined like what this is. But at our level, we are beginners. So for us, it's just a set of practices that aim to deploy and maintain machine learning artifacts. Okay, machine learning artifacts could be process data sets for just visualization, or it could be models. It could be models, right? So whatever the artifacts are from the machine learning process that you have gone through with 572, 575, 472, whatever the course you've taken, how to deploy and maintain them. Okay, maintenance is the big challenge if things have to be stable and continuously being consumed by whoever is downstream consumer of your artifact. Okay, so how to do that reliably and efficiently, and how to ensure that it's a loop. Maybe you might have to update your model or update the data that you processed. Maybe the statistics of census that you computed last year, maybe the numbers changed this year. So you have to regenerate things, right? So how do you do that in a very professional way? A bunch of practices around it is what MLOps is. And so it could evolve, maybe 2 years later, there could be further specialization into, okay, people who need to maintain LLMs or large language models could be a subdiscipline here, or people who need to maintain just visualization stuff could be subdiscipline, or people who need to do, large scale direct to consumer or client model serving, that could be a subdiscipline. But here, currently, it's just a collection of practices. And there are some areas that it intersects with. One is machine learning. Although for our course, as I said, it's a beginner course. So for us, machine learning just means simple regression at the minimum. You should know what is simple regression, as in, you're fitting a relationship between two, scalar, one-dimensional whatever quantities. So at the minimum that, obviously you can think of any, support vector machines, gradient boosting machines, or neural networks, anything over there. So that's the top, that's a left circle. And then it intersects with two other fields, which are actually not kind of our forte, which is DevOps. So DevOps is, I guess, operationalizing development experience to, I guess, deliver software artifacts, not just machine learning artifacts. Okay, that's a bigger field, much more mature and evolved. And then the last one is data engineering, which is again relatively new field. I guess 561 would be an example course that will kind of prep you towards data engineering. So it includes things like traditional things like SQL, just understanding how. It also includes advanced databases course that you have studied. So basically anything to do with data, wherever you touch data, this concepts like warehouses and analytics processing versus transaction processing, all those types of ideas. So more closer to, I would say, software for data and software for software in general, maintenance of software, intersecting with machine learning. Okay, that's roughly the trifecta here. Okay. So with that, that's just a 2-minute pitch of what MLOps is. It's really, since we are beginners, we don't have to kind of really know exactly like the 10 keywords that are related to MLOps. But in our next 6 or 7 contact sessions, these are the buckets of things that we'll look at. Okay, we'll start with something basic. The first bucket, which is called batch machine learning models and inference. Okay? So the word batch just means that we're going to just try to kind of gradually move away from something that you have been doing currently, which is you have a batch of data. It could be an Excel sheet, it could be a CSV file, it could be a query from a database. But the data is already static, residing somewhere on disk or on database. You're reading it, you build some artifact like a visualization, processing, or a machine learning artifact, and then you just need to serve it to users. Okay, who users are consumers of these artifacts, right? So we'll focus on models, but basically what I'm trying to say is that the first bucket is basically trying to get you from building models that you've tried in your laptop or somewhere else to kind of deploying them. Okay, and so the 3 sub points are just talking about different types of deployment styles. This is not exhaustive. This is not, it's not extremely differentiated, but these are the ways you can deploy your model. Let's say you have a regression model or neural network model. One of them is you can really be a software engineer, like in the sense of everything of how to stand up turn on a machine, maybe in the cloud, set up all the necessary software, and set up what is called a server, which is a certain type of software running, which can listen to requests, and it listens to requests for predictions, picks up the model, makes prediction locally, and then sends back the prediction to whoever made the request. Okay, so in the first bullet point, we'll kind of briefly discuss what web servers are in general. They're not just used for serving machine learning predictions; they're used for serving many different types of content and responses, including all the websites, including Blackboard or anything else. So that's the first way where you kind of have to work for yourself. You as in your team, infrastructure team, would kind of set up the environment where a data scientist can say, hey, here's my model, take it. It could be a pickle file or a bunch of coefficients of the linear regression model. Somehow it's consumed, and then you deploy it, okay, in a web server. And we'll see that today, some elements of it today. And the next couple of things are things which kind of try to minimize the pain or the complexity of deploying your models on web servers reliably, efficiently, at scale, and all that. Okay, there are many properties that are desired once you get into a professional setting. If you run your model today, and if you're running your laptop, the moment you close your laptop, people can't use your model, right? So it has to be put somewhere. And on top of that, that machine also has to be reliable. If that machine can only take in 10 requests per minute or per second, then the 11th request, what's going to happen is going to get dropped. Will that particular person who's trying to look at your visualization or trying to get your prediction, what's going to happen to them, right? So there are a lot of things that you need to account for while you're deploying. And the next two bullet points, serverless services and containers, help ease some of these concerns. Okay, serverless is actually, although it says serverless, it's not really, without servers. Somebody else is taking care of servers for you. The servers which can serve prediction models or visualizations or whatnot. So a couple of names in this bracket: Cloud Functions by Google Cloud and AWS Lambda functions are two examples of serverless services. There are others, but we'll try these two out actually in the next lecture. So serverless services go the other extreme, where you just care about your prediction model logic. Okay, and a little bit maybe some couple of commands, a couple of statements here and there. Let's say you wrote it in Python, then it's pretty much focused on your Python script basically, or the function even. And so you don't have to worry about the Python, ensuring that the Python environment is well run, has enough resources and all that. You have to just either through a UI or through some programming, you can just set up, okay, I want the service to run. You take care of, you as in Google Cloud or Amazon should take care of all these other concerns like reliability, scale, security, efficiency, 100 different things. Okay. So that's the extreme. So web servers, you do a lot of work. Other extreme, serverless, you don't do much of work. You at least, you know how to call your function, right? Predict, def predict, picks up the reads the model coefficients and then makes prediction. Okay. So that's the two extremes. And in between is this whole idea of containers. How many of you have heard of Docker? The company called Docker? Okay, a few of you have heard. So containers are an idea for kind of letting you handle a few things, which is what is the immediate software that is your code depends on, your model script depends on. For example, your model script might depend on scikit-learn version 19, whereas maybe if you just pip install scikit-learn somewhere else, it might install 21. So maybe there's a some regression that happens, right? So containers let you take care of your immediate dependencies, for instance, and essentially provide, effectively it's a zip file. A zip file which has a folder of your prediction model and some extra packages, so that it can be portable, so that it can be run on a Linux machine, it can be run on a Windows server, it can be run on Google or Amazon without them knowing what's inside that zip file, essentially. Okay. So there are some names here, some companies. Docker is the most popular company there, but there are actually many other companies, as you can see. And there are a lot of acronyms here. AWS, by the way, stands for Amazon Web Services, for those who are still wondering about it. And GCP stands for Google Cloud Platform. We will not explain the acronyms today, but all I'm saying is, in terms of if you had a model prepared, you had static data lying somewhere, you built a model, you could go in these three directions and kind of minimize your, and you can tune how much effort you want to put in to kind of deploy your model. Okay. Obviously, the second bullet point and third bullet point offload the effort to somebody else, so you have to pay for their effort to kind of give that service to you. Okay. So that's the first bucket: batch models, batch machine learning models, and inference. And so we'll try, beginner steps in all three directions in the next few lectures. The next bucket of things related to MLOps, okay, and this is actually, becomes interesting now, is the idea of scheduling and versioning and A/B testing. Okay, so scheduling. So currently, how many of you have scheduled a job before? A job as in a software program. Okay, 1, 2, 3. Okay, so for people, okay, some percentage of you have scheduled jobs. So scheduling, as the name suggests, is like setting up a calendar, right? Where at every predefined time instance from now to some time period in the future, something gets triggered and a program runs. Okay, so scheduling is very useful for data fetch activities or data transform activities, not just data processing activities, but also training activities, inference activities, and so on. So we'll discuss details of when this becomes critical And sometimes, actually many times, you don't have to expose your model directly to the users. So what you can do is have a scheduled job which picks up the model, makes all the relevant predictions that are possible, and just stores the predictions in a database and only exposes that database to users. Okay, you could do that. So where you're just literally, it's not machine learning anymore. It's just exposing a database to consumers, right? So that could be a scheduled job. So the names here are some example softwares that we'll play around with, called Cron and Airflow. But they are popular in the category, and they are Python environment friendly, and that's why these names are here. There are many other tools, as I said, for each of these bullet points, but we'll not get into, at least in the lecture content, we'll not get into other tools. The second one is versioning, just like we version code. So the code, by code, I mean like the two folders that are there on GitHub are course folder and the code, ML code examples, MLOps code examples folder. Those two folders are version control, as in we have, it's just like Word or anywhere else, right? So, or Google Slides, where you have a snapshot of what was the version 2 hours ago, 2 weeks ago, and so on, right? So we know how to version control our documents. Same thing happens with code, and same thing can also happen with ML artifacts. Okay, so your model, maybe you're running a training job every day or every week, and when you run your training job, at the end of the training, there are some numbers spit out. Let's say the loss, or binary accuracy or whatever, like precision recall, depends on your application. So let's say those numbers are spit out. So you can actually track, for every version, of, what the numbers are, and you can actually detect if your model is deteriorating as a function of data or as a function of its, is it still useful? Is it, has something gone bad, and so on. So you can revert back to some previous model that is still working, making reasonable predictions, having high accuracy and low error, right? You can jump back. Okay, and there are some softwares that help you do that, help companies do that, and it's very essential. Okay, just like code, you need version control for your data as well as models. And so a couple of examples here, the names just help our tools, example tools that help us do version control. Okay, and the last thing in this bucket is A/B testing. So A/B testing is just hypothesis testing, actually. But how do you instrument A/B testing? Okay, so I'm not talking about, so in the software paradigm, there's testing, which is unit testing, integration testing, end-to-end testing. Oh, there are many variations. A/B testing here is really a statistical test of, whether you're reporting model performance on offline data. It's a validation data. Okay, some accuracy numbers of 90% or 91%, whatnot. But is it really the case when the model is exposed to consumers of your model? You can actually see whether your model had that number that you're reporting offline, as in, by held out data. So you can test whether model and the previous model version, they actually, there was an improvement or not. Okay? So previous version, hopefully from previous version to this version, you did some improvements. If not, then you should just rely on the previous version, right? So you can statistically do that in the sense that you can log that data, and then once you log that data, you have two samples. You can do two sample hypothesis testing. I don't know how many of you have done 570. Okay, some of you have done 570, so you have heard of hypothesis testing. So two sample hypothesis testing is basically what you do here. Okay, but that's the once you collect the data. But how do you collect the data? How do you instrument A/B testing is also something we'll briefly discuss. The last, I guess, not the last, but so big data is a separate course. It's a core course in one of the programs. So what happens when data doesn't fit your single instance? Okay, so actually for many of the businesses which are not at, which are not too big, it's always good to be on a single machine. Okay? Single machine provides the best in terms of latency, in terms of all sorts of compute related properties that you care about. Okay? So the moment you split things across machines, which is distributed computation in general, there are all sorts of issues involved. Okay, there's network latency. So maybe the time to fetch data, if it's on the local disk versus somewhere, another computer, could be orders of magnitude off. Right, and if you have memory, if now you have memory in two different machines, and your program needs to store an object, let's say data frame, whether it stores in this memory or that memory is also, things you need to consider, right? So all I'm saying is distributed computing is hard, and that's why all these software engineers get paid a lot to deal with this, at least in big tech. But all I'm saying is as much as possible, a single machine, a beefy machine is good, but it's not, it's not possible for, many situations. In that case, you do want to do distributed computing. And one of the I guess more popular technologies there is called Spark, which is I guess subject for one of the courses in the program. But there are also other programs like Ray, which is a little bit new, and Dust, which is kind of gives you the same type of user experience as Pandas. How many of you have heard of Pandas? Okay, Pandas library for playing creating data frames and playing around with data. Okay, so that's big data and distributed training. So okay, so big data is one part, but there's distributed training, which is you don't train the model on a single machine, but also the model itself could be split on multiple machines, or there could be model parameters on each of the machines, but data is split across machines, and there's training involved. Okay, so but it just gets complicated because there's so many choices, and it's unclear which choice leads to statistical benefits and computational benefits. Okay, there's multiple angles here. So, but we'll look at just, maybe we'll just look at Spark. Depends on what we decide. And the next topic is called streaming. Okay, streaming is the same name. I don't know if you've heard of. I guess streaming is. Have you heard of Twitch? How many of you have heard of Twitch? Okay, some of you have heard of Twitch. Or YouTube, or even TikTok has streaming, right? So, so streaming is basically a way to think about data, or what is data, right? At the end of the day, data for us means tables and values and cells. But for computer at really low level is just a bunch of bytes or bits, right? Streaming really, is a little bit different from batch, which is the first word at the first bullet point, in the sense that when you think of data being streamed, you're not thinking of data at rest. Okay, so if there's a data point, let's say some row, you're just thinking about what is the timestamp, and at any given time or timestamp, where is that data? Okay, so you're not thinking of data being like queryable in a database yet. So it's more about data being passed around, and so there's always like a stream of bits and bytes going from computer to computer, and they're getting processed appropriately. Okay, so streaming is a slightly different paradigm. And it's also relevant for machine learning models, because many of the times machine learning models, especially the beefy ones like neural networks, like large language models, like if you've played with ChatGPT or Bard or any of these apps, the models are actually very heavyweight. And there's a bunch of engineers who have tried to make it as lean as possible in terms of compute, but still they are slower than us fetching, let's say, google.com. Okay, so the amount of compute needed to just get to google.com page is going to be very different from the amount of compute needed for one of these large language models to serve. Okay, so these models, so there's a problem here, in the sense the number of users may find that things are taking a long time for the queries to process and so on. So there's a way to decouple the user to the compute by just copying multiple of these. So you can instantiate multiple machines with the same LLM, and they can all be serving whenever they're free. So there's a way to decouple this by doing stream or real-time computation. Okay, so what do you do basically you deal with what are called queues. I mean, we have seen queues, right? When we go to a grocery store and check out, there's multiple aisles, and you can form a line and be on a queue. So the same idea applies to data. So data can get queued, requests can get queued, and so there could be machines which are basically servers servicing the queues, processing your requests and sending back information. Okay, so they can work at their own pace. If the servers are slow, you add more servers so that you can kind of deal with congestion. So those are ideas which are a little bit different from batch machine learning, right? So that's that bullet point. One of the things which maintains queues, a popular open source software, is called Apache Kafka. So if you have time, you can look at it briefly. And finally, there are a bunch of tools that we will briefly mention in the course. These are tools that you might have already started using, or maybe not. But basically, a good IDE, integrated development environment, is useful. It used to be, it is actually very useful to software engineers, but it's also becoming increasingly useful for data scientists and business analysts. Okay, so whether it be IDEs for dealing with databases, okay, they're actually good IDEs for dealing with databases, the good IDEs for general purpose computing. One of them is VS Code, but there are actually many others, depending on the language and all that. So that's something that we'll talk about briefly in one of the lectures. The second tool is Git. The course is hosted on GitHub, which is a particular vendor which enables social coding, but Git itself is a technology that is very useful for version control. Documents get automatically version controlled by whatever, Microsoft and Google, but we also need to know how to version control our software. And then some elements of modern Python. So you'll see that actually our code base is very, very elementary Python. Okay, it's very amateurish in some sense. So modern Python is basically, what do you mean by modern Python? Python, I guess 3.12 now, where you do types. So you kind of explicitly mention what type each input to the function is, or each object is. You professionally take care of environments where you actually build your code, write your code. You could have virtual environments, and we'll create a virtual environment today. And various things like linting, rules, style guidelines. So there are many, many different aspects of, I guess, more professional Python programming. Okay. First, obviously, you need to get used to basic programming, and then build these, I guess, enhancements. Okay. So that's the last bucket. So that's really, I went on a long discussion here, but those are the 6 buckets, or 5 buckets that will be discussed at various points in this course. Okay. Mostly, we'll follow the linear format here. So we'll start with web servers today. So any questions? No questions? Okay. Let's see. Okay, so let's we'll start with, I mean, since I'm on the slide deck, I'll just discuss the web server, and we'll actually do a quick some hands-on stuff so that you have some time to do it yourself wherever you have your machines. So okay, let's start with web servers, right? So I want to introduce this notion, and many of you might have seen this in some other courses, but it's good to kind of ground what we're talking about, especially if you're a data scientist. Let's say you're a statistician, or you've only been trained in models and model analysis and so on. So you need to understand like what's going on computers so that you can actually expose your model to users. Okay. So for that, there are some basic components. This is how many things work, including your browser being a client, and websites, all these companies, websites being servers. So what is the basic interaction here, right? So there is a client on the left and a server on the right. And the server is the one which needs to hold your program, your Python program, continuously running, Python program or some other language, but continuously running so that it can listen to requests from client. Okay. Requests for what? Request predictions, requests for process data, whatever. And then since it's continuously running, it gets requests, it validates the requests, and then sends back information that is relevant that the client asked, right? So that interaction can be done through many different ways of sending bits and bytes through wires and whatnot. But there is a very popular framework or very popular protocol that most of you have heard of. It's called HTTP protocol. Okay, hypertext transfer protocol. So that protocol is just a formalization, a guideline of how interaction needs to happen between entities. So that protocol suggests different ways to make for the client to make requests. Okay, and it's a text protocol, so it's just literally a text, piece of text in a notepad or whatever, right? So where it can use verbs like get, post, put, and so on to make requests to the server. Okay, so get request is get me this piece of content. Post request is like really posting new content or their update, or put could be like updating a content and so on. So you can make that request through the browser, through packages like request package is a package in Python that you can install and use, or even using completely unrelated to Python software as well. Something like curl, CURL is the name of a very popular command line utility for making requests to servers. Okay? It can also make post requests or get requests and whatnot. So you make those requests using HTTP protocol, and you get response back in the same protocol. Okay? So you can get back response. You can get back a text response. You can get back a video file. You can get back an image file. You can get back a more structured object, which is called a JSON object. It looks like a dictionary. So okay, it looks like a dictionary, but how can you send something which is an object, is because that object is serializable. Okay, so serializable just means that it can be stacked as like a sequence of bits and bytes and passed through the wire or whatever wireless, and then you can reconstruct back that object and expose it to the client. Okay, so it's just a dictionary. So how many of you are familiar with Python dictionaries? Everybody should be. Okay, so it's like a dictionary, but it's serializable on the wire. But I mean, it's mostly used in JavaScript language, but yeah. So that's how you send back a response. Okay, and where does the server live? As I said, it's a program that needs to be continuously running. Obviously, if we are experimenting today, we'll just run it on our own local machine. So both the client and the server will be on a local machine, so they know that they're on the same machine and they can talk to each other. But predominantly, they are going to be in different machines. Okay? In fact, client machines could be everybody's cell phones, could be their browsers on their own individual laptops, could be work laptops, whatnot. And servers can be all these remotely managed actual physical machines, or what are called virtual machines, or those containers that we were talking about, or those serverless services that we're talking about. It could be any of those, but let's say there is a machine somewhere that's continuously running the program. And so here at the bottom, I'm just mentioning EC2. EC2 is a specific name, I guess, brand name, a product name of these compute machines that you can rent from Amazon cloud vendor. But there are other names. Google Compute is the name for Google Cloud. So you can rent these machines on which you can log in and then therefore run your program. Okay? Or you can do the other things, which we'll talk about in next lectures, which is do serverless or containers or something like that. Okay? The other name here, VirtualBox, lets you create virtual machines on your own local laptop. I think except for Apple Silicon laptops, which are the new ones for the past 2 years, which VirtualBox doesn't work, but there are other paid software which do. What they do is they can create a machine for you, which is completely isolated from your own machine. Okay? It's just a virtualized machine. It looks like a laptop in itself, but it's not. It's just virtualized. Okay. So that's the basic interaction. So there's a client, there's a server. Client can be a browser, which is what is a typical much of the time that's what we use it, at least in our day-to-day so far. But the clients can be programmatic. So why do we need these other two things, curl and request, is because you could have programs that ingest predictions and then make some downstream decisions for their user, right? So for example, predictions include weather predictions. Okay, so maybe there's a service that's predicting weather for tomorrow that's consumed by a program that uses that information to kind of say something else to the user or do something else for a user, right? So these two are mostly for programmatic access, and there are many other tools there, but these two are just examples of programmatic access of predictions or results from a server. And browser, you all can, it's interactive, human interactive mode, I guess. Okay, so that's the very basic introduction to web servers, very informal. What we're going to do is actually directly jump to some getting started. So I want to, this bit is going to be a little bit boring for some of you who have already kind of set up Python and everything, but we'll actually do everything from scratch and get the repositories that we have, the the folders that we have on GitHub. We'll get it onto our machine so that irrespective of, and this is where the hiccup is going to be. Multiple people are on different machines. Some are on Mac, some are on Windows. So we want to get to a situation where at least we have that code and code examples and the syllabus and stuff on our machine, and a working Python environment on our machine, so that you can play around with things. Okay. So on this page, we're just saying maybe at the beginning of next lecture, I'm gonna just do a setup. I'm gonna just show a quick demo with an EC2 machine, which is a virtual machine that we'll rent on Amazon. The reason why I'm pushing it to next week is because if you don't have an Amazon account, it's a good time to get a AWS account. AWS is Amazon Web Services. It's a division of Amazon, which rents these types of machines, among other things. Actually, among other things, has a lot of managed machine learning services. Okay, and so there's also this question of what we're studying today is being kind of made as a service by big vendors is something that you need to be cognizant of. So you have to kind of never shy away from learning. Okay, improving your tool set. So next time we'll do the remote machine. So today we'll just level set with local Python environment and just playing around with client and server examples. Okay. Actually, even SSH we'll try next time because that time we'll have a remote machine. So we will try this thing called SSH. It's again a protocol like HTTP protocol, which protocol is just a, I guess, as I said, as a guideline of how to interact here from one machine to the other. So we'll talk about that next time. So for today, we'll try out different ways to set up, I guess, get set up with Python and try the web server examples. Okay. And while doing so, that's why there's a bunch of things that I've listed here. There's going to be a bunch of commands that I'll show. These are, so CLI stands for command line interface. So Mac users have this terminal app that you can open. It'll show basically a prompt with where you can type things. Windows also has it, right? You have the PowerShell basically, and obviously that Linux also has a terminal similarly. But the thing is, they're all slightly different products. At least Macs and Linux have the same terminal, kind of the same terminal, but PowerShell is different. Okay, so but these commands that I'm showing you are kind of commands to help you move around and basically do whatever you could have done with GUI, with the UI interface. You could have created folders, you could have placed files, you could have copied files. You can do that with the command line as well. Okay, it's not that you need to become an expert in command line, these commands or anything, but you'll see that these commands are going to become essentially statements in your scripts. Okay, so there is this package called subprocess in Python. Okay, so I don't know if has anybody used subprocess package in Python? So subprocess is so you pip install subprocess, or I don't know if it's a part of the standard library, but with subprocess you can actually call. Okay, you can call open the browser, or you can call Chrome or Firefox, and it'll open up the browser. Okay, so it could be a statement in your script, and when you run the script, it'll open up a browser, right? So all I'm saying is these commands can be used in programmatically, are like a somewhere between programmatically doing something and human interactively doing something, but also not UI based. Okay. Okay, so with that, let me actually. So any questions here? What we want to do? So what we want to do? It's 4. Yeah. What we want to do is get started with Python. Okay, I think some of you probably already installed Python. How many of you don't have Python on your machine? 1, 2. Okay, but we will cover things again. So what we'll do in the next half an hour is get Python installed, get Jupyter running, and get our 2 repositories. There's 2 code folders on GitHub that we should just download it. We'll see how to download it. And then one web server, one of the code folders has a code example of a server running and how to access it from a client. So we'll just run it. Okay. So firstly, how many of you are Windows users? Okay. So for the Windows users, have you heard of WSL2? No. Okay. So here's the homework for you guys. Figure out what WSL2 means. Actually, it's there in one of the slides at the back in an FAQ slide. But figure out what WSL2 means. It's going to be useful later on. And it actually, it's going to be useful today also, but you can kind of probably, if you already have Python installed, you don't need it. So WSL2 stands for Windows Subsystem for Linux. Anyway, and the 2 is just like the second version. It lets you get to a command prompt, not PowerShell, but a command prompt, which where you can use the same commands. Okay, so that's That's it. So that would be the easiest way to kind of be compatible with whatever you're seeing in the lectures. But okay, so there are there are multiple ways to install Python. One is just go to python.org and download the Python installer and double click and install it on your local machine. So today it'll all be on our own laptops and desktops. So we're not really MLOps right now. So either you go to python.org and install Python, or you can go to a third-party vendor like Anaconda or Enthought. There are many other vendors here who will package Python and many other things for you so that your life is easier. Especially if you're doing like just one-off analysis, like batch analysis, like if you're a data scientist or a business analyst, you're building some small throwaway or models just for your own analysis and consumption purposes, then they are great distributions to use. Okay, so those are the two ways to get Python installed. Macs and Linux, I don't know if Windows also gets by default a Linux installation, but at least Macs and Linux already have. When I say Linux, there are many varieties, but let's take the popular couple of varieties. They already come with a Python installed on their operating system. Okay, but we will install. We will do our work in a what is called a virtual environment, where we are kind of quarantining whatever things we install, like pip install XYZ that we do. It doesn't affect rest of the system. It will only be installed in a local folder. You can delete that folder, and rest of the system is not affected at all. Okay, so just to recap, we have a couple of ways. You can go to python.org and download and install on any of your machines, or you can use Anaconda or Enthought to download. Okay, so let's yeah. So then so this is I would suggest if you haven't never installed Python, I would start with this one because it makes it super easy. So I guess this link here, Anaconda distribution for Python, is what you would install. Okay. So I'm not showing the installation here. What I'll do is, since I'm actually on a Linux machine, so I already, as I said, Mac and Linux already have Python installed in their operating system, so I don't have to install another one. So I'll skip that. Okay. So this is a command prompt that you can. This is a terminal, just like PowerShell or on Mac, you can open terminal. You don't need to get to here. First, install Python. Okay. For me, I'm going to show a little bit different way because, as I said, Macs and Linux already has Python, so I'm going to just directly start with creating a virtual environment. Okay. So there are multiple ways to create a virtual environment. What I'm showing you is like using command line, but you could use if you're using Anaconda download, then there's a slightly different way to install Python. So let me actually do the other one as well, just for. Good. So Anaconda has this Python, I guess, runtimes for any multiple different Win setups. What I'm going to do is to try this one because my machine is a Linux machine, the one I'm using here. But whatever is the machine you use it. So typically your machine would be the 64-bit x86, which is like if you have an Intel backed machine, like if your Windows machine is based on Intel chipset or Intel processor, then it's this x86 64 makes sense. But Macs, just follow what, just go with M1 Mac if you have a silicon based Mac, M1 silicon based Mac. If you have an older MacBook from before 2021 or something, then you can go with first one. Okay. So download any one of them and install it. So since I'm on Linux, so let me download that. So I'll download that to show the way to do it, way to do command line things in with Anaconda. But for now, let's actually jump back to command line. So what I want to do is create a virtual environment, so that whatever things I install for my web server demo and whatnot, they're all contained in this folder, so I can, not worry about the rest of the system. Okay. So the way to do it in command line is Python 3 is a so for example, Python 3 is in the path. Path just means path where executables are located. If there's an executable like a program that's on the path, then it is available as a command here typically. Okay. So Python 3 is an executable which is on the path. So if I type Python 3, I'm already in the command. I don't want to type Python, but it already tells you which version of the Python I'm running. But this is where many of the challenges in MLOps are, that versions, like my version that you see here, will probably not be the same version that you have. Even the Anaconda stuff that we downloaded will probably be something different, 3.12 probably. But to deal with all this, virtual environment is actually a great step. Okay. So what is the virtual environment, right? So that's system Python. So what I can do is Python 3. Sorry. So Python 3 has a module called venv. Okay. So Python 3 or Python 3.10 has a module called venv, and it's also there in 3.12. So you can create a local folder where all the things will be installed for you, whatever we install in the future. Okay. So let's call it, convention is to just use the same name for the subfolder. So just to give you a sense, so this folder currently doesn't have anything. ls is a command to list the files in this directory. If you've used PowerShell, it's the same. I think it's the same command, or maybe dir/p or something. But basically, you can list files. There are no files in this directory. I can also use the UI, like a file browser, to see that there are no files currently. And then I'm just trying to create a virtual environment. So if I type this command, I got the prompt back. So this blinking means that the previous whatever command you requested got executed. Success or failure is another thing, but got executed. Now, if you look at the folder, there is a folder called venv. Okay, so this venv folder has some files underneath it, which will help you, create your virtual environment. Okay, I keep using the word virtual environment. It's just an abstraction where you're restricting all the software related to your current working activity, which is like playing around with web servers, into that subfolder only. So that doesn't affect anything else in your operating system. Okay. Yeah. Doesn't have to be live, but I'm just gonna finish this in like 10, 15 minutes. And then the remaining hour of today's session is that you can try this slowly. Yeah. But if you're already fast, then you can just follow along. So source is another command. Maybe it was not listed in that slide deck, but source is a very standard way to instantiate this virtual environment. So what are we doing with instantiating the virtual environment? I can show that to you. Source. So this is very standard. Okay, so if you're seeing it the first time, it's new. But if you do 100 different Python scripts, 100 different Python projects, it always is the same 2 steps. Okay. create something self-contained, especially if you're working with two different Python projects, let's say one involves a web server thing, one involves machine learning thing. They might have different requirements. One might need NumPy 1.21, another one might need one older version of NumPy. How would you install both of them at the same time, right? It doesn't make, it's going to be hard. So these two commands, create a virtual environment. You can give any name as a second argument here, and that would be the name of the folder. And then that folder has a subfolder called bin, and has a script called activate. Okay. So if you on a command line, whether you're on Mac or Windows, you can type this, and then you'll see that a new thing has come up, which is this prefix in the command. Okay. This says that now we're going to only look at Python installations, even the Python executable. Everything is restricted to that folder. Okay? It's in that folder actually. So you can you don't have to know this command, but if I type which Python, it says it's actually in the Python is an executable in the subfolder. Okay, so this is how you let's clear this. This is how you create a virtual environment. Now, I think I was downloading. Yeah, so I downloaded Anaconda for Linux. So let me copy that. Copied, I would have just moved it. It's a huge file. It's a 1 GB file. So the way you install it, I'm just showing you this way is because when we rent machines on Amazon and Azure, or in Google and Microsoft or wherever, those machines, most popular machines that are rented are mostly going to be like this. That's why I'm just showing you this way. On your local machine, you can just double click and install Python. And Anaconda, let's install Anaconda. So the command that I'm writing here, a couple of commands, I would say, if you're curious, all I'm doing is making that file executable and then executing it. If you guess, that's exactly the same as double clicking the file. Okay. So I'm not doing double clicking here. I'm making the file executable and then executing the file. Okay. So executing a program is like /execute the program name. Okay. It'll show some license, which you should read, especially in a professional setting. Wants to create something somewhere. So let's install Anaconda as well. Okay. So that's going to take some time. Let me go here. Okay. So now we have our local Python environment, whether you install Anaconda or whether through python.org, or if you already have Python like this. First step, whether if you're only based on Python, which is system Python or the python.org, it's good to make a virtual environment. Okay. On Conda, Conda has its own way to create environments. You can also do the same thing that what I just showed, like when create commands. But Conda also has a way to create their own way of creating virtual environments. Those are called Conda environments. And so we'll see that. That's why I'm installing Conda on the other tab, just to show you how to create an environment there. Okay. But all we're doing is restrict our activity to these folders. Okay. So now you can just do pip install XYZ. So we'll see what we want to install in a second. Right. So this pip install is going to install any program. Let's say request, right? Let's say I click request, which is something I think I showed you in a slide. Request is a library to make a request to a server to send back something. Right? So you can just do pip install. This particular thing got installed only in that venv subfolder. Okay. So what we'll do next is go to our course page. Actually, we don't need a course page for now to demonstrate this, but let's go to this page, which is MLOps code examples. Okay, where do I get that? I told you there are two resources. One is the link to the slide deck, and the other one is the link to that second repository. Okay, the name we use is for repository is just a folder, code or other files basically. So this is the second link here. That's the link that I opened. So the first link is the slides, which is the tab there. We don't want the slides now. We just want the second link. From there, we're going to download the code. Okay. And how to download it? You can click on the green button and it says download a zip of this folder. Okay, this folder is just nothing but a bunch of folders with Python files. Actually, you can just explore it by clicking on those folders, and they're all relevant to. I guess most of them are relevant to our course, so we can play around with them. So we can download it either as a zip file. So if you click on it, you'll get a zip folder. Put it in a place where you're gonna play around with it. Okay, maybe a desktop or documents or wherever. Or the way we're going to do it is actually use this link here. Okay. I'm just going to show you one way to do it, but you don't have to use the link. I mean, you can click download. It'll just download the folder, download the zip file, right? So I'm going to use this link. What is the benefit of using the link? Is that this code here, as I said, it's version controlled. Okay. Let's say tomorrow I say, oh, I made a mistake in one of my web server examples. I fix it. Okay. So tomorrow, are you going to re-download the whole folder and delete the previous folder? Okay, that's going to be pretty wasteful. So if you do the link way, which I'm going to show you now, then you can just do a local command to update your folder to mirror whatever the folder was on GitHub. Okay, so it's a little bit more efficient way to get updated on your local folder. To update your local folder to whatever the state was on the remote machine, or in this case, the GitHub website. Okay, is the reasoning clear? I mean, you can download it, download a zip if you want to play around with this. That's totally fine. But if you want to be a little bit more efficient, you can use the link. And how to use the link? Copy the link and go back here, and you can type git clone. Git is again a command line utility that's generally present in both Mac and Linux, and it will be present on Windows as well if you install WSL2. Okay, it's just that if you don't have it currently, just download it. Okay? The marginal benefit I just told you is all about just if I update, instructor updates that folder, the folder on the website, you can just write a small command to update your local folder quickly. Okay? Otherwise, you have to download, re-download 100 different copies of zip files. It's just not very manageable. Okay, so that's the git clone of that link. Okay. So what happened in this folder right now is that Anaconda installation of Python, which we are not using. I just installed it. I just showed you that we installed that one as well. But we have this folder that we just downloaded from the github.com website. And this is something that we created 2 minutes ago, right? So now we have the folder. Now what we're going to do is let's see. I'm trying to decide between first set up the client or first set up the server. So which one is okay, let's actually do the client side first. Actually, let's do the server first, because the client, we already have a browser. We can make a request to the server from the browser as well. So let's actually just cd is a change directory command. So we'll go into MLOps code examples, and here's where, if you have an IDE, it's good. We can always open the files in that folder using Notepad or any of your favorite text editor. Maybe not Word or something, but something like something which can read plain text files or Py files. I'm going to use code. Okay, code is just command is just a short form for VS Code. VS Code is a IDE provided by provided by Microsoft. It's called Visual Studio Code. It's just a what is it, right? So it's a basically an interface. Trying to see where the cursor is. So when I type that command code and dot just means the current folder. Open the current folder in VS Code. That's all. Okay. So you could have done the same thing. You could have opened VS Code and then open that, go to file and open folder and whatnot, right? So can you guys see this? Or I think I need to. Is this here? I don't know what the. Uh, I don't think I should be editing fonts here, but can you guys see the? I mean, you don't have to see all this right hand side. I mean, it'll be good if you can see. Oh yeah, I can just use this. Okay, let's forget about settings. So this is the editor, where I just want to show you the server program file. It's only a few lines, and then we'll execute it and get a sense of how that works a little bit. Anybody having any questions at this point? So what I'm showing right now may seem different than what you are used to, only because I'm not using UI, because you are already familiar with how to use UI. So you can download a file. That's literally just click download to get the code zip file. Anaconda, you already get a Python environment, right? So yeah, virtual environment creation is, as I said, those are the two commands to use it, to create it using command line, but you can also create it visually as well. Okay. Yeah. So I think so far what we've done is I talked about Anaconda and Python installation. We got it installed. We just downloaded our code base, and we're going to look at our code file. Okay. That's it. So the code example that we're going to look at is in this folder called Flask. Flask is a very lightweight web application framework. Okay, so Flask is a very popular way to create very lightweight, simple web server programs that can serve your prediction models. It's not a very professional software, but it shows you what is the basic idea behind these web services. So in that, we can look at an example called regression. So it's just a folder below a folder called Flask example regression. You can see this, by the way, on that link also. So you can just go to github.com, just double click the folder, you can see the file. So let's click on that, called Flask simple regression service. Okay, actually, let me, yeah. I'll increase the font size as needed, but basically this is the whole program. So it's 31 lines of not much going on, actually. So let me actually even delete some of these things. What is it? Yeah, we have the folder. In that folder, I mean, I just opened that folder in VS Code. That's it. VS Code is an IDE. You don't have to open it in an IDE. You can just open it in a notepad or whatever is a convenient tool for you. Okay, so this is even a simpler function here. Actually, let me. Okay, so this is a simple function. So let's drop this. Okay. So line 1 is related to our web server part. So, we're not going to focus on the model, ML model here. The ML model is actually this model. Okay. So it's a simple regression model. So input is one-dimensional, output is one-dimensional. Let's say the coefficient, the slope is 2, and the intercept is 1. So 2x plus 1 is the regression line between input and output. Okay. So given an input x, we're just producing 2 times x plus 1. Okay, that's the model here. So you can change this to any model, any regression model, and it's the same idea. So let's focus on import line 1. Okay, line 1 generally Python imports, right? So we are importing from a package called Flask. Okay, so the package is not installed currently in our virtual environment. We have to do pip install that package. Okay, we'll do that in a second. The package is importing a couple of helper functions and a class from which we're going to create an object. That object is named app. Basically think of this as we are creating a web app. The app is so web app or server app is just is name of an application that we're going to constantly run and wait for us to send a request for a prediction, and it's going to respond back with a response, predicted value, right? So we're going to create an app, and there is a prediction function here at line 10, okay, that we're going to talk about in a second. But that function gets invoked. Okay, so when we run this Python script, it's running. Okay, it's like constant. It's like while true, it's continuously running. Okay, it's just waiting to listen to HTTP requests. When a client sends an HTTP request, okay, to this program, and we'll talk about the details in a second. But when you get a request, this package somehow maps the request route to this function. Okay, so when you make a request, let's say google.com, right? Google.com request is different from google.com /search or google.com/flights. Those two are different, right? So google.com goes to wherever shows you the Google search page, and google.com/flights might show you the travel search page. Okay, so two different pages, right? So all I'm saying is this decorator here, this function decorator, which I've, I guess, highlighted there, is basically that's the purpose of this Flask web framework, to kind of connect a request at some location to a function that can respond to that location's request. Okay, so here currently we are saying send a request to /, but you can say /prediction or predict, or let's say my predict. Then whatever the URL is, whatever the server's address is, /myPredict will be the place where this function will be invoked to respond back with my regression model's response. Okay. So this is called a function decorator. How many of you have heard of function decorators in Python? No. So function decorator, nothing complicated. It's a function that adds some extra bells and whistles to the function below it. Okay, so this is just a shorthand notation that was introduced in the language, maybe in Python 3. Basically, it's a way to wrap an existing function, which is our predict function, with some extra bells and whistles that are needed to respond back to the client's request in this case. Okay, so function decorator, just think of it as like if you have a return statement in a default in this predict function, the function decorator is adding some extra content while doing the return statement. Okay. So what is the predict function doing? So that's where another help comes from this Flask package. The Flask package is a function called or this object called request. Okay. This request object gets populated with whatever the client requested. So if the client says, "Hey, give me a prediction for give me a prediction for 10." Okay. So what should the prediction be? 10 times 2 plus 1, right? So maybe 21 is the prediction. So when the client sends the value 10 through this HTTP protocol, server receives the value 10. Okay. And Flask helps put that value 10 into this dictionary. Okay. Args is just a dictionary in this request object. And Flask helps put that value into that dictionary with x:10. Okay, so the key is x and the value is 10. Okay. And okay, if X isn't 10, then we actually try to make prediction. Okay, that's this try catch is again a pattern in Python. So we can actually drop we can actually drop it. But if you drop it, you'll see internal server errors in the client side. So let me just keep it. Yeah. And then if X is in the arguments, then I'm just returning back. The server is returning back, okay, you sent me whatever you sent me. That's what I'm going to say is I'm just creating a dictionary with what they sent me as the input, with the key value input, and what you sent me as a value of it. And then my prediction for that input, which is where I'm calling the model function. Okay. So this is somewhat straightforward. And then this function here, JSONify, is just a way to, as I said, JSON is a way to kind of serialize the dictionary, at least from our perspective. So JSONify is just a simple helper function, again, provided by the Flask package to just respond back with this dictionary, which is the argument to that function in a way that's possible through the HTTP protocol. Okay. Else, if did not fail, if the client did not send X, then you just send back saying, hey, we did not succeed because you did not even send, or in X was not given. Okay. So it's just a Python script which is saying if X is present, when the client sends me a request, if X is present, hopefully let's make a prediction for X. Okay. Hopefully is because there's a try catch. Try catch. If you can't make a prediction, we'll pass here. But if X is not even there, then we can just say input X is not even, it's not there. Actually, we should say input X is not passed. Okay. That's it. So that's our function, right? That's our script. And with this, let's actually go back to so we can actually invoke the Python terminal right below also, but I don't want to show VS Code capabilities today. So let me come back to our terminal. So we are in a virtual environment, okay? So that if we install anything, we need to install one thing here, which is the Flask package. Hopefully that's restricted to this project only, or this folder only, okay? So pip install Flask. Okay, so now we have Flask. So let's go to that folder. For example, sorry, it's a long folder of a folder of a folder. So we are in the folder which has that file that we just edited. Okay, this is the file. So we can just run, there are many ways to run it, but let's just run it in a little bit non-standard way. We'll just do Python file name.py. Although the Flask package, if you look at the documentation, they say Flask run or something. Okay, so I ran that program, and this is where that program is continuously running. Okay, I'm running the program locally, so there's no really a separate client or a separate server. So they're all two programs running on the same machine. So client will get to in a second. But this is kind of, we have gone from getting Python installed, downloading our code base, slightly changing, making some changes. I mean, they're just cosmetic changes, but changing a little bit on our server code and then running the server. Okay. And we install the prerequisite for it, which is just Flask. Okay. But in a real project, there'll be a lot of dependencies, NumPy, SciPy, scikit-learn, 100 different things, depending on your model. And so it's saying that currently, since we didn't configure anything, it's just saying, oh, this is for development and it's available at this location. Okay, it says you are able to access this service, which is able to make predictions at this location. Okay, this location has this a bunch of numbers separated by 3 dots, right? So that's actually the addresses that are used worldwide. Okay, so when you go to google.com, the word google.com is translated to one of these 4 numbers separated by dots, and then you actually go hit Google servers where that address is located, and then you can get back the page. Okay, so this is basically and this is like the address, it's going to, University Hall has a address, right? 601 South Morgan Street. So it's the address of the location. Okay, so let's just go to that location. It says not found. It's not the current location. Yeah, I think I made a. Oh, that's a good point. Actually, it is not found because, I mean, you can see in the log here that that location, that route, is not mapped to any function. That my function was only mapped to a location called slash my prediction or my predict, something like that. Let me just see what the location is. My predict. So, for example, we could have done another function, right? At that location, default location, when you just type 127.0.0 and say hello, right? Return something, right? So okay, so we could return a string, right? So let's see if we can. Is it 5,000 or? Okay, I think I need to do something here. Um, okay, actually that function didn't work, so it's internet server error. But let's actually go to that my predict location first. I'll fix the hello world or whatever the default was in a second. So my predict route works. The other route has an error because we ran this. Apparently, Flask doesn't have an underscore version. Flask itself is not imported. We did from Flask import X, Y, and Z, but we did not import the module itself. So that was the error. So let's actually come back here. Let's fix the let's see the my predict function. I hope you guys can see. So we hit the root. The root triggered that function. The function saw that there was no X passed. If X was not passed, the response should be success is false and input X was not passed, right? So that's what we achieved. And so now we need to pass an argument X, right? So one of the ways to pass it from the URL itself, from the browser itself, is to use this convention, which is a question mark, the key, and the value. Okay, it's all strings, right? So question mark, the key is going to be X because that's what the server is expecting, and the value is going to be, I don't know, 10. Okay, so X and 10. Okay, so that's how you make the client pass a request with some data. One of the ways to pass a request from the client side. This is called a get request. And if you, now I guess make the request, then you see that, okay, input is 10. And in fact, it's saying it's a string. And we convert the string to float and then actually pass it to our model. The model said 2 times 10 plus 1 and then return back the number. Okay. So we did that. And then, as I said, the minor issue here is we didn't import Flask. But if you import it, then you should probably see it, which is not the case. Yeah, actually, the reason why it's not, when I make code changes, it's not updating the server process. But there are that's just a development convenience that if you change the code, the process restarts. It's not restarting, and that's why we're seeing that error. So I restarted it, and so you can see the Flask version. So by default, it's just saying it hit that other function. But if you actually go to /my predict and give X is equal to 43, then you get some number, right? So this is at least the client server loop that we have seen. Okay. Let's see. I think I vastly exceeded my time to show this, but I just want to, yeah, I just wanted to. I'm going to show a programmatic way to access it next time through the request library. I just want to install Jupyter, but I don't want to do it right now because it's just, it's easy to install Jupyter. But next time early on, I'll show how to use a different client, a request library to make the same request. But more importantly, next time for the web servers part, we'll try AWS instance. Okay, so if you're interested, you should try to get an AWS account before next time, or a Google Cloud account, any cloud account, wherever. They do require you to verify kind of your information. So in the sense, you need to have some credit card or something. But they do have a free tier for 12 months, and we're not going to exceed anything. Actually, it's just for web servers, trying out web servers, so it's not really being used too much. Yeah. So what I want to do is give you a 10-minute break, which I was supposed to give 20 minutes before, but 10-minute break. And then those of you with laptops can try this out. And there are actually other examples in the same class examples folder. It's just I wanted to show the simplest one. You can try them. They have more dependencies and more complications. Yeah, so take a 10-minute break, and after the break, you guys are kind of, if the ones with laptops with still enough battery, you can try things out here. If not, you can leave. Thank you.